I got cut off right there at the end. So you go for this direction, you go for this direction. Those give you locus points, which are on your quadratic. Then you can sketch. Your domain should have been all real numbers, and your range should have been from -5 to infinity. Make sure you include that -5 so it's with a bracket. And then your distance from your focus to your directrix in this case is 4 again. Okay, moving on to the next page. So it says describe the characteristics given its equation. So if you're given -2x plus 1 squared plus 4, you need to know that this is in vertex form. So this is in vertex form, which tells me that my vertex is going to be the point opposite of the inside, so -1, 4. So -1, 4 is going to be that. Then you need to decide, is it concave up or is it concave down, and why? So concave up, concave down just means which direction does it open to? Is it up or down? So we have this negative in front, so we know it's going to be concave down because A is negative. If it's concave down, that means it gets flipped upside down. It looks something like this. All right, so that means that it's going to have a vertex that is a maximum point because it's like the top of a mountain. So again, this can be a maximum for the same reason, because your A value is negative. And then it asks, how many zeros should the graph of f of x have? Give me your reason for your answer. So if my vertex is up here, and I told you that it's going to be shaped in this direction, all right, that means that it's going to look something like that. I did it extra skinny because the 2 is telling me that it's going to have a vertical stretch. So how many zeros? Well, it should hit 1, 2 times. That's not the perfect sketch, but it should hit twice, so it should have 2 zeros. Because your vertex is above x-axis and the quadratic is concave down. Okay, your wording doesn't have to be exact, but you need to be in that ballpark. Like, you need to show that you have an understanding as to why exactly it is the way that it is. Okay, next thing. State the domain and range. So again, your domain is always all real numbers. Your range in this case, because it's concave down, it's going down forever, and the highest it hits is when it hits the vertex, and that's included, so that should be a bracket. Okay, next thing, graph quadratic functions given the equation. So when you're graphing, you can be given it in standard form, you can be given it in vertex form. So if you're given it in standard form, in order to graph, you have to find what the vertex is. So to find your vertex in standard form, that's x equals -b over 2a. That's going to give you your x value for your vertex. So if I plugged in, I'd have -8 is equal, or over 2 times 2. This is going to give me 8 over 4, which is equal to 2. So the x coordinate for my vertex is going to be at 2. Then to find what your y coordinate is, you take that and you plug it in. So if we plug it in, we get this. So we just took that 2 and we plugged it in for our x's in our equation. 2 squared is 4 times another 2 is 8, minus 8 times 2 is 16, plus 5. 8 minus 16 is -8, plus another 5 is going to give us -3. So our vertex is going to be at 2, -3. The only other point that you're basically given when you're in standard form, this plus 5 is always going to be your y-intercept. So we know that our y-intercept is at 1, 2, 3, 4, 5. But remember, you need 3 points to graph. So remember you have that axis of symmetry. So that axis of symmetry comes and it cuts everything right through the middle. All right, and it tells you that everything's gonna be the same on one line or one side as it is on the other. So this point right here, if this is my axis of symmetry, that means if it's 2 units over here, it's gonna be 2 units over here. And then you have 3 points, and then you can graph and it looks something like that. If you don't notice that, then just start plugging in X values, see what you get as your Y values, and start to plot them so that you can get what that shape's gonna be. Okay, next one. This one is now in vertex form. So in vertex form, we have our vertex. It's gonna be opposite of what's here and here. So our vertex is at the point 1, 5. 1, 2, 3, 4, 5. Here's our vertex. This negative tells us that it's gonna be flipped this way. And so to get your other 2 points, there's a couple different ways you can do it. So again, you could start plugging in points. So like if you plugged in 0, figured out what you got, and then if you plugged in 2, you could figure out what you got. You'd have 3 points and you could go. Or if you know, like, so right here, this negative is telling us that our A value is -1. So that tells us if we go right or left a unit, that we're going down a unit. So we'd go left 1 unit, down 1 unit. That gives us our -1. Right 1 unit, down 1 unit. That gives you your -1. And then you can kind of start to sketch what that would look like. You could also solve this quadratic and figure out what your zeros are, and then you could plot those and you could connect that way. There's really a lot of choices. All right, I'm gonna keep going in the back. Find the zeros of the quadratics when they're real. So if you ever want to find the zeros, 2 ways you can do it. I mean, there's more than 2, but 2 main ways. So you can factor or you can use the quadratic formula. So I always like to try to factor first, just because I feel like the quadratic formula, there's just more room for error. But if you try to factor here, multiplies to give us -18, adds to give us -7. We know that's going to be -9 and 2. And again, because it's a leading 1, I know that my factors are just going to be x minus 9 and x plus 2. To find your, so those are your factors. To find your zeros, you set your factors equal to 0. So x minus 9 equals 0, x plus 2 equals 0. I would add 9, x is equal to 9. That's my first 0. I would subtract 2, x is equal to -2. That's my second 0. Okay, so that's how you find it using factoring. So then, like, if we were going to come over here and factor this one, numbers that multiply to give me -3, add to give me -12, there isn't any. So this is something that is not factorable. So if it's not factorable, or if it's something that you don't want to try to factor because it's big numbers or something like that, like you guys had a problem on your homework where if you had tried to factor, you would have been finding the factors of -25,000. That's crazy. That's when you plug it into the quadratic formula. So quadratic formula, you have -b. So -b is -12. So we're going to have 12 plus or minus the square root of -12 squared minus 4 times a times c all over 2 times a. Okay, you're not going to have a calculator on the test. So if you're not going to have a calculator on the test, then you need to make sure that you can multiply that stuff out. So if you start multiplying that stuff out, all right, you're going to get 12 plus or minus 144. I should have given myself a little bit more room, but 144. And then -4 times 3 is -12. Times -1 is going to give us plus 12. This is all over 6. And so from here, we're going to say, okay, this is 12 plus or minus the square root of 156 over 6. Okay, you cannot divide 156 by 6 because that 156 is inside the square root symbol. So it is like off limits. You can't touch it, any of that stuff. So you need to see if you can break down what's inside that radical symbol. The only thing that is worth breaking down 156 with is perfect squares. So if you start to think, okay, is 156 divisible by 4? Yes. Is it divisible by 25? No. Is it divisible by 16? No. Like, go through all your perfect squares. So 1, 4, 9, 16, 25, 36. Once you get past like the small ones, you don't really have to check any bigger because that's usually not going to happen. So 156, I'm going to come up here to the top real quick. Oops. The square root of 156, okay, can be broken down into 4 and 39. So 4 and 39, if I take the square root of that, it becomes a 2 on the outside and it's a 39 on the inside. Do I think you're going to get a number as big as 156? No, I don't, but who knows? So we can rewrite this whole thing and then you can divide by the 6. So 12 divided by 6 is going to give us 2 plus or minus 2 over 6 is going to give you, I'm going to come up here because I want to write it nice and big. So 12 divided by 6 is going to give you 2, and then plus or minus, you have 2 square root of 39 over 6 right now. So this is going to reduce to the square root of 39 over 3 because 2 over 6 reduces to a third. This would be your final answer. If you need help with breaking down radicals, there's like 1 million videos about it that you guys can watch. Okay, I'm going to start a new video for the next part so you guys can hop on there if you need it.